Welcome again to Math 800 Pre-Algebra. Today we are doing section 3.3, solving application problems with one unknown quantity. Objectives: 1. To translate word phrases into algebraic expressions. 2. To translate sentences into equations. And 3. To solve application problems with one unknown quantity. Objective 1. Translate word phrases into algebraic expressions. Example: write each phrase as an algebraic expression. Use x as the variable. Note, expressions don't have equal signs, so none of your answers should have any equal signs. A number plus 2. You can write this as x plus 2 or 2 plus x. The sum of 8 and a number. You can write this as 8 plus x or x plus 8. 5 more than a number. You can write this as x plus 5 or 5 plus x. A number increased by 6. You can write this as x plus 6 or 6 plus x. Notice all of these words mean addition. Also notice that there are always two ways we can write them. That is because addition is commutative. That means order doesn't matter. 9 less than a number. This less than means subtraction. Subtraction, as we know, order is very important. Subtraction is not commutative. So, it is very important. Is it 9 minus x or x minus 9? If you are not certain which one it is, pick a number to use as a sample. So, let us say we asked 9 less than 11. What is 9 less than 11? 9 less than 11 is 2. In order to get 11 and 9 to come out to be 2, you'd need to take that 11 minus 9. Since the 11 is a stand-in for our variable, we know it has to be x minus 9. Notice the order is not the same. The 9 came first, but that's what we subtracted. Be very careful with subtractions. 9 less than a number is that number minus 9. A number subtracted from 3. In this case, the number is being subtracted from 3, so the number comes second. This is actually 3 minus x. Again, think of a sample number. If you had asked 2, what is 2 subtracted from 3? 2 subtracted from 3 is going to be 1. So it'd have to be 3 minus 2. That's the only way you were going to get a positive 1. A number decreased by 4 is going to be x minus 4. And 10 minus a number is going to be 10 minus x. So be very, very careful with subtraction. If you switch the order, you will get the wrong answer. And it's not always the order that they came in. Here, 9 came first, but that's what we're subtracting. Here, the 10 came first, but that's actually the first number. Very, very careful with these. Some additional words and expressions. 8 times a number is 8 times x, or 8x. The product of 12 and a number is 12 times x, or 12x. Double a number means 2 times, so 2 times x. The quotient of negative 6 and a number is negative 6 divided by x. A number divided by 10 is x divided by 10. This one is a combination. 15 subtracted from 4 times a number. Remember our order of operations. Multiplication happens before subtraction. So we have our 4 times, and then 15 is subtracted from that. So 4 times x minus 15. The result is always an equal sign. Is will be our equal sign. Our next objective is to translate sentences into equations. Notice equations have equal signs. So all of these will have equal signs. Be very careful. If you're working with expressions, no equal signs. Equations have equal signs. If 5 times a number is added to 11, the result is 26. Find the number. We are going to let x represent the unknown number. Our phrase was 5 times a number added to 11 is 26. 5 times a number is 5x. Added to 11, added to is a plus, 11 is 11, is our equal sign, and 26 is 26. Be very careful with the word is. Notice, is in this sentence twice. If 5 times a number is added to 11, the result is 26. Only this one was an equal sign. This one was not. That's what makes these so tricky. You can't just look for the words and write them down. You have to read it and understand what you're reading. Now that we have an equation, we can solve it. We want to get the 5x by itself, so we're going to subtract 11 from both sides. Remember that 11 plus negative 11 is 0. We can rewrite that as 5x equals 15. Then to get the x to have a coefficient of 1, we will divide both sides by 5, and we get x equals 3. Therefore, the number is 3. You can check your answer. If 5 times a number is added to 11, the result is 26. We said the number was 3, so we need to show that 5 times 3 plus 11 is 26. 5 times 3 is 15, 15 plus 11 is 26. Quick note about equal sign. Even though we were only focusing on the 5 times 3, they still have this plus 11 here. Had you not had this plus 11 here, you could not put all these equal signs, because what you would have been saying is that 5 times 3 is 26, and that's not true. 5 times 3 plus 11 winds up being 26. Objective 3. Solve application problems with one unknown quantity. Solving application problems. There are 6 steps to solving an application problem. The first step. Read the problem once to see what it is about. Read it carefully a second time. As you read, make a sketch or write word phrases that identify the known and the unknown parts of the problem. Some people find it very helpful to actually draw on the words as you're reading them. Either underline them or use a highlighter and highlight them, but it can be very helpful to mark up the actual words you're reading. Step 2, there's actually 2 different versions of this. If there is one unknown quantity, assign a variable to represent it. Write down what your variable represents. It is very important that you write for me what your variable represents. The examples we will see in this section will only have one unknown quantity. In our next section, we are going to have problems where there is more than one unknown quantity. In that case, assign a variable to represent the thing you know the least about. Then write variable expressions using that same variable to show the relationship of the other unknown quantities to that first one that you don't know anything about. Step 3 is to write an equation using your sketch and word phrases as a guide. Your equation has to use the variable you used in step 2. Step 4 is to solve the equation. And step 5 is to state the answer to the question in the problem and label your answer. It is very important that you label it appropriately with the appropriate units. Again, you will lose points if you don't use the correct units. Lastly, step 6 is to check whether your answer fits all the facts given in the original statement of the problem. If it does, you are done. If it doesn't, you have to start over again. Also, when you're checking, make sure you've answered the entire problem, particularly for cases where there's more than one unknown thing. Also, make sure the question makes sense. I will always give you problems where the answer is logical. What I mean by that is if you're trying to figure out, for example, how fast a car is going, it is not reasonable to get an answer of -2 miles per hour. A vehicle is not going to go -2 miles per hour. That's a big tip-off that there is a mistake somewhere. So don't only check the original statement, but check to make sure the answer is logical. Example. Heather put some money aside in an envelope for small household expenses. Yesterday she took out $20 for groceries. Today a friend paid back a loan and Heather put the $34 in the envelope. Now she has $43 in the envelope. How much was in the envelope at the start? Step 1 is to read the problem. The unknown is the amount of money in the envelope at the start. The known is that she took out $20, put in $34, and ended up with $43. It is often helpful to rewrite in shorter phrases the important parts from the question. Again, your other option is to underline some of these pieces within the problem. So underline took out 20, underline put the 34 in, underline now has 43. Here, how much was in the envelope at the start, that is our unknown. A lot of times it will be restated at the end of the problem. Step 2 is to assign a variable. We're going to let m represent the money at the start. Recall that the unknown was the amount of money at the start. That is why we're using that to represent our variable m. Step 3 is to write an equation. Our money at the start is our m. We took out $20, let's subtract 20. We put in $34, so add 34, and we ended up with $43. So this has to equal $43. Now we have to solve our equation. If you need to, rewrite subtract 20 as add a -20. It's up to you whether you need to do this step. Combine our like terms, the -20 and plus 34, or negative 20 and positive 34, and you get m plus 14 equals 43. To get m by itself, subtract 14 from both sides, and we wind up with m equals 29. Step 5 is to state the answer. There was $29 in the envelope at the start. Lastly, check the answer. If you started with $29 in the envelope, and you took out 20, you had $9. Then you put in $34, and 9 plus 34 is 43. At the end, it had $43, and that matches. Notice our answer is not 43, this was just a check. The answer is the $29 that was there to start with. Example: Michael has completed 5 less than 3 times as many lab experiments as David. If Michael has completed 13 experiments, how many experiments has David completed? Read the problem. The unknown is the number of experiments David did. Notice again that's that final question. How many experiments has David completed? The known is that Michael did 5 less than 3 times the number David did. We also know that Michael did 13. Assign a variable. Our unknown was the number of experiments David did, so we will let n represent that. Our equation. The number Michael did was 13. That is 5 less than, which is minus 5, 3 times David's number. Again, be careful. 3n minus 5 is not the same as 5 minus 3n. If you switch this, you're going to get the wrong answer. Now we must solve our equation. Once again, if you need to, you can rewrite subtract 5 as adding a negative 5. We want to get the 3n by itself, so we're going to add 5 to both sides. We will get 18 equals 3n. Then we'll divide both sides by 3, and we get 6 equals n. Step 5 is to state the answer. David did 6 experiments. That is your answer. Step 6 is your check. 3 times David's number is 3 times 6 is 18. Less 5 means subtract 5, that's 13. Michael did 13. Those two match. Therefore, the answer is that David did 6 experiments. That concludes section 3.3. Now I need you to complete the worksheet for section 3.3. Once you're done with that, check the key or come to class and we'll go over it. Then complete the online homework for section 3.3 through My Math Lab, and lastly start on section 3.4.